about how are games coming? Getting pretty close? Yeah? Okay, that's good. So it's today's our last day of the first half of the semester. So obviously, um, the project is basically the concluding thing. Um, I will post a Canvas uh, kind of like a little survey type thing because I'm doing this exact class the second half of the semester, and so I'd kind of like some feedback from you guys as to you know how things have gone because I have the opportunity to make immediate changes next semester. I mean next half of the semester. So pay attention to that. I'll send out an announcement with that and some the kind of rest of the end of business kind of thing or end of semester. End of class, not end of semester. We're not there yet. Um, so just pay attention to Canvas for some of that stuff. The other thing is, I told you guys about the Carnegie Museum visit thing, which I'll send more info when I have it. At this point, all I have is a date and a time. Um, so it's on the 21st of April, which is that's the Saturday before Dead Week, not the Saturday before finals, because I thought that might be a bad idea. Um, and it'll be open to the public from 1 to 3. And so I'll ask, if you guys are able to come and you want to come about noon. I'll get a shit ton of Jimmy John sandwiches. And I figure that's enough inducement to get you to, yeah, just shit ton of Jimmy John's. Yeah. Okay. Um, yeah. Because I figure you guys probably get enough pizza in your lives. Well, okay. Would you rather have pizza or Jimmy John's? Let's put it that way. Pizza? Yeah. Okay. Well. All right. Well, we'll figure it out. But yeah. Anyway, so I'll get food. And like I said, when I have a little bit more info, I'll send it out to you guys along with like a sign up sheet. Um, and let me be clear, you guys are not obligated to do it because your class is over at that point. But I think it'd be a lot of fun and think of the children, right? So, well, okay, fair. Yeah. The guys in the other half section, though, are going to be, there is an element of if your game sucks, there's sort of some public shaming that goes on when the kids are like, this game sucks, and then they storm off to another one. That's worth it every time. Yeah. Well, sort of. I mean, the other benefit of this is that, the guys in the second half class, they won't be done with their games by the time that we get to the museum, right? Because this will be like us doing this last weekend. But you guys will get to see their stuff and vice versa. So that'll be fun. Um, and then my retro guys will probably be, I want to bring them there too, to show off at least a little bit of their stuff. Probably will do all of their stuff in emulators because I don't want to haul my super valuable, super rare equipment over there. I might take one of them just to demo like this is what a computer was like in 1984, and I will stand next to it and stand guard. So yeah, anyway. So that yeah, project's coming along okay. Yeah, hopefully. Yeah. Okay, so what I wanted to do today was sort of to do a little bit of a transition between, so some of you guys are going to go on and take CS111, or some of you are about to graduate and are going to go into the real world, and you don't do real programming with block stuff like this for the most part. And so I kind of wanted to give you a sense of a bridge of where this can go now that you've for the most part mastered this language, right? This language doesn't have, it's pretty feature rich, but it's not super feature rich. Um, it has, as we've seen, a couple of, well, many irritating idiosyncrasies. Every language does, okay? And part of it is, right, who this language was designed for. So what I pulled up here was our space shooter that we had been working on, kind of back earlier in the semester, just to use it as an example for what would this look like if we were programming it in Python, okay, or JavaScript, both of which are real languages. They're text-based languages, so you don't have code that sort of looks graphic like this. Okay, now, and this is one of the things I really like about MakeCode, because all you have to do is hit that button and bam, it translates it for you, and vice versa, right? So if you paste in code from Python and then you go to blocks, it'll show you the equivalent blocks, if it's possible to convert that to blocks. Now, it's not always possible to make a one-to-one conversion, but most of the time it does at least a pretty good job. Okay, so let's just kind of go through. Let me stop the emulation. Just kind of go through and look at what is going on with how this compares to block stuff. Okay, so the first thing would be that we have here, we have the definition of a function. Okay, so functions start out in Python with def in front of them because we're defining a function. Okay, and then the thing that follows it is the name of that function, in which, in this case, it's on be pressed. Okay, whatever. And then we're defining a variable here called invincible. It has the word global in front of it because basically in this language, at least by default, every variable is global. Okay, so what's the difference between a global variable and a local variable? And what would be an instance where we've used them? Yeah.
I mean, a global variable is available anytime.
Anytime, any place, to everything in the entire program, right? Whereas a local variable, we use this, for example, it may not be in this particular version of the program here, but what did we do with, we had the Sprite data extension, and we've used that in a few ways because, for example, we could set the player's health to be a specific number. Okay, but we also did something where we set the enemy health so that the enemies had like 3 hit points or something, just make up a number. But if that's the case and I shoot one enemy and it deducts a health point, does it deduct a health point from every enemy? No, it's only deducting the health point from that specific enemy. Um, and so that's the difference between global and local. Okay. Now, in this case, invincible is global, and the reason that it was global is because we created it here in our variables tab. Okay. Anything that we create there is going to be a global thing, and then anything that's like that, we use the Sprite local variables. What was it? Um, where was it? The arcade data. Where was it? Arcade text, this one. Okay. Um, the arcade data one, which um, gave us a bunch of extra things down here to under the Sprite tab, right? Those would not be global. They would be tied to a specific object. Okay. So that's one major difference. Okay. The other thing that we want to see is sort of how structurally do we read this? Okay. So I've highlighted in this case just the let me pause that. Highlighted the this particular functions definition. Okay. And you'll notice that stuff is tabbed over in kind of a nested form. So what does the tabbing tell us here? Like, what's the point of it? It makes it more readable, to be fair, right? But it's more than that. Okay, so what happens if invincibility is 0 and I hit this button? Yeah, invincible gets set to be 1, right? So I programmed this function to basically toggle between being invincible and not being invincible. Okay, so what should happen if in the if case? Okay, in this case, what did we have happen? It just set the invincibility to 1. Could I have had like 15 things happen then if that was the true? Yeah, okay. And all of them would be tabbed over like the line that says invincible equals 1. Okay, so in Python, the way you know um, how control structures are nested together is purely handled by tabbing. Okay, so if I were to untab that invincible equals 1 over, the code would not work the same way. Okay, now the other thing is you see that there's the colon after the if statement and there's another one after the else and so on. You have to have colons basically after stuff that you're defining. So you see def on pressed, we have a colon, global invincible, all we're defining is that the existence of a variable. I could say global invincible equals 0, but I don't want to do that. And then, yeah, okay, so we've got those statements. So that construction, how did we tell whether or not what was part of the if and what was part of the else in the block code? Well, let's go to where the B button pressed part was. It's over here somewhere. There it's pretty obvious what's inside, right? That this is what happens if the if part is true, and that's what happens if it's not. Right? So this is the advantage of block code, or an advantage, is it makes it very obvious to see what the structure is. Would you guys agree? Okay, whereas here in Python, once you know the convention that it's all about tabbing, then you can see the structure, right? No. Yeah, okay, great. All right, so this has defined a function, okay? And then this thing here is basically what it's done is it's bound that function to the controller, okay? So this function, as it stands right now, has nothing whatsoever to do with a controller, okay? I could call that function anytime I wanted. Now, when do I want to call it? In this case, when I hit the B button. Okay, that's the trigger that I want to have happen. Okay, so this line right here basically binds that controller B, that button, when it has the event being pressed, it is to trigger the function on B pressed. Okay, I could rename this here to chicken and waffles and then change this to chicken and waffles. Okay, the name of it doesn't actually matter, although wouldn't it be kind of logical to choose a name that's reflective of what it's supposed to do? Yeah? Okay, so yeah, so this thing is using the object controller that has a sub-object, the B button. Okay, so this dot stuff is kind of what I want to talk about next. Okay, so any questions so far? No? Okay. All right, so this dot stuff. So in Python and also other languages, things are sort of oriented in a view of objects, and then objects can have sub-objects, or they can have methods, which would be little pieces of code that go with them. Okay, so for example, the controller is an object. It has as sub-objects a bunch of buttons, up, down, left, right, BA, and if you were on a real Nintendo, select start also, right? Okay. And so the controller is an object, and B is a sub-object of it. So controller.b is going to access the B button within the controller. And .onEvent is going to be a method that basically says, okay, when something happens, do something. What thing am I checking to see if it happened? I'm checking to see if the type of event for that button is that it's being pressed. Now, could I also check to see if it's released? Sure. Okay, and maybe that's important in a game. And then the thing that goes after it is what function do I want to trigger on that event? And in this case, it was the on B button press that we defined earlier. Okay. And so you'll notice that there's a lot of other places where there's the dot stuff. Okay. So for example, we've got also a similar thing for the A button. Okay, an A button pressed event and bind. And here is something that we used um, where we used some dot stuff to access sub objects. Okay, so we've got here projectile dot start effect. Okay, so up just 2 lines above it, that's where we actually created the projectile. Okay, so projectile is an object, and then the dot start effect tells it to apply the effect to that object. Okay, which effect? The spray effect. Okay, whatever, and there were a bunch of different ones that we could pick from. And then how long did we want it to affect it? 100 milliseconds. Okay, so 1/10 of a second. Okay, so we picked some effects, whatever, right? But the projectile dot start effect, if I change this to my sprite dot start effect, right, then my player's ship would start having those effects appear on it. Okay, so does it? What I'm trying to get across is that the method start effect is something that sprites have. Okay, or well, projectiles in particular. Okay, and I can have one sprite have this effect happen, or another sprite just by referencing its name. Okay, we no. Okay, and then so the definition there. You see the projectile equals sprites dot create projectile from sprite and then assets image blah blah blah. Yeah. Okay. So what's going on there? Well, sprites is a master class. It's an object, and all sprites are members of this class. Okay, fine. And we're going to create a projectile from a sprite. Okay, and when I say from a sprite, I kind of mean at a sprite. So where could you create projectiles? They had to start at an existing sprite, right? And that makes sense in our game here. Where did we want our projectile to start from? Our rocket ship, right? Not just any old place. Okay. Now, some of you guys may have run into the fact that that's a little irritating because what about if you wanted to have, for example, uh, fireballs raining down from the sky in your game? Well, the fireballs you probably handle as a projectile, okay? But can you just create them any old place? No, you can only create them at a sprite. So how would you create them at a sprite if there's no sprite? You'd have to first make a sprite. Okay. Now, that sprite could have no art attached to it so that it's invisible to the player, but it still has to kind of exist. Okay. Or at least in this language. Okay. Um, right. Okay. So, the assets.image, you see the stuff with the quotes there, how it has the dot, dot, dot. Basically, it's just truncating that because just to make it a little bit more easily readable. And in this case, it just has the name in there, Dart1, which was a particular art asset that we had. But some of you guys have run into this. Why is it so hard to do custom graphics in this thing? Well, their own editor is kind of clunky, okay, and in particular, it doesn't just have magic image import features, okay. The real reason is the way that it's actually storing images internally is not the way that you would store an image internally just on any old computer. Okay, they're actually using a more old school technique for it. Okay, so let's say that I wanted to store an 8 by 8 image. Okay, 8 pixels by 8 pixels. How much data is it going to take to do that? Well, okay, that's a question, right? Let's just figure out how much does it take to store a single pixel? Well, okay, also a fair question, right? Well, one way that you could do it is to store the red, the green, and the blue separately for each of pixel, okay? And if you do 8 bits per pixel, then that gives you 256 shades of red, green, and blue. And if you mix those, you get a pretty comprehensive color palette. It's not perfect, but it's pretty good. Okay. All right. But that takes up then 3 bytes. Okay. So how many bytes in what's a bit in a byte? Let's just make sure we're clear there. Okay. Let's back up. What is a bit? Huh?
3 bits is a pixel, you said, correct?
No. Sorry. Yeah. A bit, okay, a bit is like a switch. It can either be a 0 or a 1. It's either on or it's off. That's it. Okay, so that's a bit. Okay, we group these together into larger units. Okay, 8 bits is defined to be a byte. And byte, because we have to be cool in computer science, is spelled B-Y-T-E. Okay, because, yeah, that makes us super awesome and gets us all the ladies. Okay, um, okay, so 8 bits, which is a single byte, can encode 256 different things. Okay, now here's a way to think about that. If I ask you to flip a coin, how many outcomes are there? 2, heads or tails. A single coin flip is like a bit. Okay, if I say I want you to flip 8 coins or flip a single coin 8 times, same thing, right? And you write down what the outcomes are, it could be heads, tails, heads, or whatever. How many total outcomes are possible for after you flip 8 things? It's 256. Okay, how do we get 256? It's 2 to the power of 8, right? So if I give you 2 coins, how many outcomes are there? 2 to the 2, which is 4, right? Because you could have heads, tails, heads, tails, or tails, heads, right? And so if there are 2 outcomes on each coin flip, and does the second coin flip have anything to do with the first coin flip? So the things multiply, okay? So every additional coin, you're doubling the number of potential outcomes. Does that make sense? Okay, so if you have 8 coins, there are 256 different outcomes, ranging from all heads all the way up to all tails, and all the mixy ones in between. Okay, so what that means for us, because we're not here to flip coins, is if you have 8 bits, you can encode 256 different things, different patterns. Okay, so let's say that I choose that for each pixel, I'm going to encode 3 numbers: the amount of red, the amount of green, and the amount of blue. Okay, and each one of those I'm going to do as an 8-bit number. Okay, that means that each pixel takes 24 bits to store its color. Okay? If I made them all zeros, that would be black. If I made them all ones, that would be white. And if I, did like all red but no green and no blue, then I'd get the shades of red and so on, right? So and I could mix the colors kind of however I want. Like if I did 2/3 red and 1/3 green, then I'd get kind of like a well, whatever color, right? Um, okay, does that kind of make sense? All right, so it would take 3 bytes, 24 bits per pixel. How many pixels are there in our 8x8 image? So if I have an 8x8 image, how many total pixels are there? 64, right? Just 8 times 8. If each of them takes 3 bytes, then how many total bytes have I spent here? 64 times 3, which is 192. Okay, 192 bytes. Now, does that sound like a very big number? Well, yeah, I mean, this is kind of a matter of perspective, right? Like, you guys all have a computer open, right? Go into one of your programs or something, and if you're on a Mac, you can hit the Command I key. If you're on Windows, you can right click and, get info or whatever. Tell me how big that object is. Just pick an object. So that's something that's sitting on your desktop.
Like the inspect deal,
Um,
a regular computer.
yeah, regular computer.
That
No, that's not what I meant. Sorry. I meant go into like your file browser.
Oh, yeah.
Okay. So, for example, you have a Div3 stats homework, and it is 23 kilobytes. So, do properties down at the bottom, right? So, you can see that it's 22.3 kilobytes. It actually takes up 24 kilobytes on the disk. And okay. All right. So, what else did you guys find? Okay. How big was the picture of your cat?
1.5
Yeah, 1.5 megabytes. Okay, so a megabyte, depending on who you ask, is a million bytes. There's actually two conventions on this. It's either 1,000 squared or 1024 squared. Um, but yeah, whatever. That's what it used to be. The problem is that that's not the correct use of the metric prefix mega, and the SI people got a little irritated with this. So yeah, Mebibyte, Mebibyte. But that sounds ridiculous, so nobody actually says that. Okay. Yeah. Okay. All right. So the picture of his cat was 1.5 megabytes, 1.5 million bytes. And that's just for the picture of his cat. Okay. So if our image we said was 192 bytes, that's for just one single image, right? Well, how many images do we have in our games? Presumably a lot more of them. Okay, so let's kind of go old school a minute and talk about how would you have done encoding of sprites way back in the day, in the 80s, right? Because that's what this is trying to sort of remind us of is 80s programming in some sense. Okay. Okay. So 80s computers and game consoles. What which ones come to mind? What was one of the 80s game consoles? Yeah, the Atari, the NES. Okay, I'll take the NES as the example because the Atari, uh, yeah, it's just irritating. Okay, so the NES, how much memory did this thing have?
64 megabytes.
Kilobytes. 64 kilobytes was its address space. The entire thing. Okay, and it gets worse because some of that is reserved for the video chip, the sound chip, and so on. So that most games had 32 kilobytes of program ROM and 8 kilobytes of character ROM, which is where all your sprites would go. Okay, that's it. I know the look of horror is how you could fit that much in there. Well, you have to be clever, okay? And in particular, the way that you would be clever is so let's take a sprite, okay? And let's just use an 8 by 8 sprite as an example, right? So I can think of an 8 by 8 sprite as just a grid, and hopefully I can count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's my sprite. Now, if I store red, green, and blue with 8 bits, it takes 24 bits or 3 bytes per pixel. That's too many. We don't have that much space. Okay, so what the Nintendo did, the Commodore did, in various ways is they said, okay, sorry, you don't get all those colors. You only get a subnumber of colors. On the Commodore, you only got 16 colors, period. Okay, that's it. The entire machine can only produce 16 colors. Now, you could play some tricks. So, like, how many of you guys have seen those images going around on Facebook periodically? Like, there's one with the dress. This was a while ago, right? Where you look at it, and some people saw that it was black and yellow, and some other people thought that it was blue and white or something. And then everybody gets in massive arguments over it, and it's the same image, right? So, you can, if you're clever with how you put two colors next to each other in patterns, you can trick your brain into seeing something that maybe isn't there. But let's just say all you have are 16 colors. Okay. If all I have are 16 colors, then what I'm going to write down for each pixel of the sprite is a number from 1 to 16, or really 0 through 15. Okay. And so what happens is each sprite becomes, rather than being an actual image, it's a paint by numbers kind of thing, where I say, okay, I want to put color number 0 here, and color number 1 there, and color number 5 here, and color number F there. Because, by the way, if there's 16 things, here's how we count them: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay, that system is called hexadecimal, and we use it like all the time, and have for decades. So then how much data is it taking for me to store an individual pixel? Well, if I've got a number 0 through 15, how many bits does that take? 0 through 15 means I have 16 bits, right? How many coin flips are necessary to get 16 possible outcomes? 4, okay? Because 2 times 2 times 2 times 2 is 16. Okay, so what previously we said would take 24 bits per pixel now only takes 4 bits per pixel. That's a 6-to-1 reduction, right? That's pretty dang good, right? And this is how, for example, sprites on the Commodore work, okay? Or on the Nintendo. I'm glossing over a few details, but that's basically the idea, is that you do kind of a paint by number scheme. Yeah, and that's how the images are actually stored in this thing, is they use a paint by number scheme, okay? And then if I have that paint by number scheme, what else do I need to have? So do you guys remember doing like paint or draw by number when you were kids? Yeah, with coloring books and things. Yeah, so how did it work? Right? Yeah, but was there a key somewhere that said, okay, 0 is this shade of red and green is that number 5 or whatever, right? So there was a key someplace that told you how to change the number into the appropriate color, okay? And if there wasn't such a thing, then what happened? You could make it up. And you could say, okay, I want color 0 to be this gray, and I want color 1 to be this pink, and whatever, right? And then everywhere you saw 0 in your paint by image thing, you'd color it with the gray. And maybe you'd get something that, like, you colored it correctly, but it looked kind of psychedelic. I don't know. I mean, you guys were probably not dropping acid in elementary school, were you? Yeah. Hmm. Well, you just didn't have a good elementary school experience, right? Yeah. My first psychedelic experience was watching Fantasia, um, or especially Dumbo. You guys know that one scene in Dumbo, the elephants on parade, where it's like, what is going on here, right? Yeah, that was like complete acid trip. Okay. Um, yeah. Okay. So, right. So this is actually how MakeCode basically is storing images, is not as a grid of pixels like the image of your cat, but more in the paint by numbers kind of scheme. And this is why it's such a pain in the ass to import them. Okay. Because if we wanted to take his image of a cat, what we would first have to do is basically reduce it from the format that it's in into sort of this paint by numbers kind of thing. And there is at least one sort of kind of program we found to do that, but it's not all that handy.
It also takes up like several hundred lines of code.
Yeah, because what it's doing when you do that is it's actually writing down the paint by numbers array of all that data. Okay. And so, like here, Dart1, right? Imagine that there'd be lots and lots and lots of stuff in between these quotes. Okay. And we were just talking about an 8x8 sprite, but of course, the sprites in MakeCode can be much larger if you want. On the Nintendo, they were more limited. And so if you wanted a larger object, you had to make it as a combination of multiple subsprites, which, okay, fine. The original Nintendo could display up to 64 sprites at a time, but irritatingly, you could only have 8 of them on a horizontal row. And if, yeah, I know, right? And if there were more than 8 on the row, then what you would get is this flickering kind of effect. So if anybody played Mega Man, the Mega Man games, right? So play Mega Man, and when there's lots of enemies and crap going on, and then like you explode or you're shooting things and there's stuff flying everywhere, you sometimes see that flickering. That's what's going on. Is that the machine can't draw more than 8 things on a horizontal row. Nope. Yeah. So it was just a limitation of the hardware. And I mean, the Mega Man games, I think, really push the hardware to its breaking point to some extent. And because you can see it, right, where there are places where the game noticeably slows down. And, you know, it got better over time as programmers got more adept at being efficient. But yeah, okay. Okay, so now in our case here, Dart1 is sort of a stand-in for that data of however the dart is painted. And we've got all that stuff set up in the assets. And in this case, all of the assets that we used in this particular game were things that we just imported on our own, or sorry, not imported on our own, that were just built into MakeCode. So we didn't have to make any of this stuff, okay, which is what he's talking about. With the image thing where it'd just be a block of hexadecimal, which is so readable, isn't it? Yeah. Okay. Okay. So yes, that's a little bit about the image format and stuff, and maybe one of these days I'll get to writing a better at like an image editor that can, or actually what would be really nice is like a Photoshop plugin where you could like export to MakeCode or whatever. But yeah. Okay, so well, what else did we need in this game? We also had the overlap stuff, right? So, for example, we had here. What happens if our player overlaps another player, or I mean the enemy? Or what happens if our projectile impacts an enemy? We needed 2 separate cases to handle that, right? Okay. And so we have them here. Okay. This first one is what happens if, let's see, this was if we hit another sprite. Or sorry, we hit a, sorry, we hit the projectile. The projectile hit the other sprite. Okay, or no, wait, no, it's not. Let's just make sure that we did. Ah, yeah, it is. Okay, sorry, because it's sprite of kind projectile, right? And let's see, where were we here? Oh, Sorry, I was reading the wrong one. It's this one. Yeah. Okay. So you see down there at the bottom, okay, that we've defined a function. What should happen if this function is triggered with a sprite and another sprite? Well, okay, it will do some stuff, but let's actually go down to the bottom line here, the binding event first. Okay, so we want to see, have two sprites overlapped. Okay, so that's sprite on overlap. And then this part would be what kinds of sprites have overlapped. With our space shooter, we had two different situations, or at least to start with. And then if you guys added power-ups and stuff, then there were more, obviously. But what situations did we have? Well, the player sprite could intersect with an enemy sprite. Okay, so there's one kind. What was the other kind? The projectile could intersect with an enemy. Okay, and of course we could have created more. So like, did anybody, when you guys did your extension of this, make it so that the enemy started shooting back? Right, that could have been one of the things that you had done, right? In which case we'd have to have yet another kind of overlap situation. Okay, so that thing down there that I've got highlighted is going to say, all right, what kind of overlap situation are we checking for to trigger that function? We're checking for when it's a projectile kind overlapping with an enemy kind. Okay. We could have also had like projectile type 2, let's say projectile 2, intersecting with the player. Okay. Or something else. So then this on line 24 there, that's the other overlap event, okay, which was what? That one handled when the player intersected an enemy. Okay, now does that make sense looking at line 24? Okay, the first sprite was something of kind player, and the second sprite was something of kind enemy. Okay, great. Right. Okay, and yeah. Okay, so then what happened if the enemy got hit by a projectile? What did we do to the enemy when we shot it? Yeah, we applied 1 point of damage, and then we said if its health is less than or equal to 0, destroy it. Okay, and the reason we did it that way is because presumably an enemy sprite could have more than 1 unit of health, right? And maybe multiple or different enemies could have different health amounts. Okay. And the less than or equal to 0, we did that basically. This is kind of a cover your butt thing, because let's say that you programmed a power up that allowed you to apply 2 points of damage. Well, what about if the enemy has 1 health point and you hit it with 2 points of damage? You apply the damage and it now has how many health points? Okay, if you check if that's equal to 0, is that going to be true? No, but you still want to kill the thing. So that's why you wanted to use the inequality there. Okay, just to kind of catch that edge case. Okay, does that kind of make sense? No. Okay. All right. And the rest of it is, I think pretty similar to what we've talked about, okay, so far. But you see, like here, my enemy.x equals randint 5 to 155. So what was that doing? Yeah, we had this enemy spawning at the top of the screen, and we made the x coordinate of it a random number between 5 and 155. Okay, and why did we pick 5 and 155? Those didn't come out of thin air. Yeah. Yeah, because how wide is the screen? 160 wide. Okay. And so this way our enemies would appear almost entirely on the screen. And then how much health did each one have? 3, and that was set on that line. Okay. And then here, after the sprite came into existence, we set what kind it was. It was a type enemy. Okay. We could have had multiple enemy types. Like, did anybody create a boss as their extension to this? I mean, but you could have, right? Okay. So there, you'd make that a separate kind so that it would have more health or whatever. And then the data here, right? So my enemy dot x. Well, what does dot x mean? My enemy is the object. X is the property within it. And dot x, in this case, what do you think it means? It's whatever its x coordinate is. Okay. And so what built-in data objects did you have for these things? Their position, x and y, their velocity, x and y, their acceleration, x and y. There was, I think, a friction one. We never actually used that. Has anybody used a friction variable to make it like you're walking on ice or something? No? Okay. Well, then you all fail. So, okay. So, I mean, this is kind of a super quick crash course to Python. And of course, the other thing is that what we're looking at here is not just Python. We're looking at Python implementation of MakeCode. Okay, so MakeCode is defining a bunch of things like the scene object or what it means to destroy a sprite. Okay, and we're using that library in our program, and it's all just built in here. If we were to do this with sort of vanilla Python, we'd have to define what all of this stuff meant, and it would be a lot more complicated. Okay. And of course, the code would get a lot more, exciting, shall we say. Okay, now if I go over to JavaScript, right, well, a lot of it looks pretty similar. Okay, we still have the tabbing, but the tabbing isn't actually required in JavaScript. It's just there because it makes it easier for humans to read. And how you know things are grouped together is with these curly braces. Okay, so the if part is everything inside that pair of curly braces. Now, what's maybe the problem with these curly braces? What can you guys imagine could happen? If you have a really big program, how many curly braces are there going to be? Lots. And guess what is impossible to find at 1 in the morning? The missing curly brace. And there will always be a missing curly brace someplace because you're human, right? Or they'll be mismatched. You'll have too many left curly braces and not enough right ones, or they'll not be nested correctly, right? So, yeah, so that's one downside, I think, to C or Java or JavaScript. They're all curly brace languages, and finding that curly brace is freaking annoying. Okay, but there's this language is JavaScript is still used, so you have to do it. Okay, all right. So most of this looks relatively similar, not identical, but pretty similar. But it's just expressed in a different language. Okay. So for those, I mean, really for all of you, right? Because hopefully this class is not the last time you're going to do any programming in your entire life. Okay. Even those of you who are about to graduate. So what are you going to do with your life? Seniors. In what? Management. Okay. What are you going to do with your life? Okay. You might have to do some simple programming. Okay. Maybe it'll be in Excel. pretty handy, especially in the financial world, right? Um, and relatively simple, right, to do stuff with it. Does anybody have any interest in going into game design as a career? Right. All right. So um, they're not going to be using Python for most stuff, but it'll look sort of like this. Okay. So let me show you guys actually one other kind of scripting system. Yeah.
What is most commonly used? Like, software? I know like Unity,
Unity and Unreal Engine, I think, are the two biggest ones. Yeah.
and they don't use like C++.
They do. So I'm going to show you Unreal Engine because I happen to have it installed, but um, uh, the preview's out, but I'm not sure when the full launch will be. Probably sometime this year. Um, okay, it's loading. It just takes forever. Let me minimize this. And make sure it's actually loading. There it goes. Okay. Because one thing I want to show you is that, uh, well, hopefully you've seen that block-based code is useful, but also limiting, right? In the sense that it can get a little messy and hard to organize. But block-based coding is still actually used in the industry. And in fact, Unreal Engine is a good example of this. Unity has a similar kind of thing. So if you wanted to program in Unreal Engine, you have two options. You can either use what's called Blueprint, which is their visual system, or you can do it in C++. Okay. With Unity, it's in C sharp instead of C++. Okay, whatever. But they also have some sort of visual scripting system. I don't think it's as robust as Unreal Engines, but that's okay. And sort of the story for how this started was in the. So, how many of you guys have played an Unreal Engine game? Okay, which game?
For the Crisis number, where
The Crisis is its own engine. Yeah.
I had to have Bioshock Infinite.
Bioshock. Okay, the Bioshock games all used various iterations of the Unreal Engine. Okay, I'm glad that nobody has admitted to playing the game that starts with an F and ends in a night. Yeah, Fortnite. Okay. Yeah, of course everybody's played Fortnite, right? I mean, how else could I make the "where we dropping boys" jokes, right? Okay. I mean, unless you played PUBG, so which actually is also an Unreal Engine game, but yeah, which is to say Fortnite but with real guns, or you could look at Fortnite and say that's cartoon PUBG, right? Okay. Anyway, so Unreal Engine games, but let's go back. So the Bioshock games use these. What's the earliest game you remember ever playing that was Unreal Engine? Perhaps.
The Arkham games.
I think some were.
If I remember rightly, I played a sign. That was the first one. I'm not. It's like I know for sure that it was. I definitely had to have played like an older one.
Okay. Well, so Unreal Tournament, God of War, right? Um, and if you go way, way back, right, the original game was called Unreal. Real creative, I know, right? No, it's Unreal Create. Aha. Okay, so that game basically was Epic's. It wasn't their first game, but it was their breakout that made them a lot of money. Um, and where they really made their money was by licensing the game engine to other developers, because developing a game engine takes a lot of time and a lot of money. Okay, And it would be really nice if this would load sometime.
It sounds like your MacBook doesn't want to stay.
Yeah, it does. And I think it's crashed actually because, well, we'll just let it sit there while I talk. Okay. Um, well, actually, you know what I'll do is let's just do, we'll just do this to give you kind of a taste of it. Um, I just want to show you some images here. I just want a quick example. There we go. They have a ton of like online courses and stuff. Um, so anyway, just kind of look at this image up at the top. I know it's a little bit blurry, but you see how it's got all these little blocks and they're connected with these sort of white lines or colored lines. And what those are indicating is the white lines are indicating execution flow. So how, what comes before what. And the other colors are indicating basically different types of data. And it's things are color coded. So things that are true false are color coded in red. Things that are numbers or groups of numbers are color coded in kind of a greenish color, right? And so it's kind of like Makecode in some sense, right? Things were color coded to sort of organize what um, how they were functioning within the program. Okay, so the flow is from left to right here rather than from top to bottom. Okay, whatever, right? That's just a different way of doing it. Um, and this language still exists, and in fact, is only getting more robust. Okay, and now the reason for it getting more robust we'll talk about in a second, but also where did it come from in the first place? Okay, so in the original Unreal Engine games, and this is back in the late 90s and early 2000s, there was a scripting system in them called Kismet. And that was used for like you built a world, and then maybe you wanted to have something like a door opens and then an enemy spawns and then the lights go out or something like that, right? So kind of a simple like sequence of events. And so what they had was sort of a very simple scripting system that kind of was visual that you could just real quickly put something together and have it trigger a sequence of events. Okay? And they're like, hey, this is cool, right? And then they realized, we could like make the entire thing based around this. And so it is possible to program an entire Unreal Engine game using nothing but Blueprint. Now, one thing that's different about it versus MakeCode is in MakeCode, you only had one window of code. In Unreal Engine, things are grouped into different places. So stuff that has to do with, let's say you have let's say that you have two different types of enemies, like an orc and an ogre. Well, the code that goes with the orc, you would only see it if you opened up the orc's code. And the ogre similarly, right? So you could keep, okay, orc code is here, ogre code is here, stuff for my world is there, stuff for level one is over there, and keep everything kind of organized in a way that MakeCode doesn't really do that, right? It's all just one big pile, okay? Um, Okay, so basically, the reason that they port resources into this is because who programs a game?
Game programmers.
But it's not just the game programmers. The artists need to program. The people who are building the worlds need to program. Um, the storytellers need to build to do stuff with programming. Okay, does your storyteller necessarily know thoroughly C++? No. Okay, so let's assume that all you have is C++ programming. So who's going to be able to do the programming? A programmer. So the story guy has to write a bunch of crap down and send it to the programmer, and the programmer has to sit there and put all that in when he could be doing other stuff. like actual programming. Okay, so this scripting system exists basically to free up the programmers to concentrate on real programming, like the stuff that needs a professional programmer, and allow world builders and artists and other people that are part of these teams to still do lightweight programming without having to bother the heavyweights. Okay, and so that's, I think, one reason why that they've poured a lot of resources into developing and augmenting this system, is so that it actually speeds up development, because it means everybody can be programming together. Okay, and if you want something like to make a door that'll only unlock if the player has the red key, right? You shouldn't need the guy who's doing all the heavy graphics programming to do that, right? The guy who builds the world that has the door should be able to just handle that. Okay. All right. So, yeah, and maybe eventually this thing will have loaded, because yes, my computer does sound like it's about to launch into space. Hey, we've made it to 83%. Okay, so progress. It's been a while since I've run the editor, so it may be taking time. I was just going to show you guys one example from that I've done. Just to give you kind of a taste of where you could go with this sort of stuff. Okay, so let me just hit the play button. You can see what the game is. Oh, okay. It's going to look janky for a little bit because it's got to do some shader stuff, but um, oh, yeah, okay. We're going to have to wait a minute for it to do this, but because so what's supposed to happen, and it's compiling the shaders, which shaders are like micro programs that tell things how to look. So I've got this where it will, when you click on one of these things, it will highlight it either kind of a yellowish color or a reddish color. Okay. And obviously you can guess what the game is. Yeah, tic tac toe, big shock. Okay. All right. So if I wanted to program tic tac toe, and I'm now regretting us not doing tic tac toe and doing that card flipping thing instead. I'm so doing tic tac toe with the next group. Okay. What all do we need to program? Well, we need to program some sort of turn system so that it alternates between two players. Um, and in this, I used red and yellow instead of X and O, but okay, same thing, right? Um, and then I also need to make sure that a player can't select a block that has already been selected. Okay. And then the third thing would be I'd need to have some sort of system for checking whether or not somebody won the game. Okay. How many ways did we say there were to win tic tac toe? Depends on how you count. It's either 8 or 16, right? Because there are 8 ways for one player to win or 8 ways for the other. So either way, right? It's either 8 or 16. Okay, so we'd have to check those. And then we also, how would we know, for example, if the game was in a stalemate situation? Yeah, if there were no available blocks to be clicked, but yet nobody had won the game yet. Okay, so we added that in. And, it wasn't huge to do all of this. Okay, so it's doing all these compilers. Let me open up some of the actual code here so you can get a. Okay, so here's some of the code, okay? And for example, here's, reset block is an event, okay? We're going to set is active to false. You see how it's this kind of reddish color? That's for true false data types, okay? I'm going to set the material of a particular object to either blue or, uh, um, oh, sorry. to blue, and blue is what I used if it was unclicked. Okay, and then if it gets clicked, well, I have to see, is it already active? If it's not, that means it hasn't been clicked before. I'm going to make it active. I'm going to figure out who clicked it. And then depending on who clicked it and whose turn it was, I need to either set it to be the sort of orangish yellow color or the red color, right? So you see I've got this thing here, a branch. I've got a condition plugged into it, and the true case goes up there and the false case comes down there. Does that kind of look how we had an if then else in MakeCode? Right? So what went into an if then else block in MakeCode? You had the thing at the top with the pointy ends, okay? And pointy end dudes in MakeCode were what? The things that had pointy ends on either side. What kind of data was that? They were Boolean, true, false things, right? Is something equal to something or whatever, right? But they could only be true or false, okay? Well, the condition, is a thing that has to be true or false. And the red color in this thing tells me that, okay? And I was using here player turn to be either 0 or 1, for whose turn it was, okay? And then we also had the stuff that would be in the if block and the other stuff that would be in the else block for what would happen if the true case was true or not, right? And so what do I want to do if it's true? I came up here and do all of this stuff. And what do I want to do if it's false? I go down there and do all of that stuff, okay? Looks different. It's organized visually a little different, but the idea is pretty similar, okay? And this is millions of dollars have been spent developing this engine. Okay, so that was just the stuff for how to do just the little block, each individual block. Okay, I also had to have code that said how to spawn 9 blocks. Okay, and then I also had to have stuff for what was the game mode, right? And how do I do stuff to reset the game, okay? And so all of these things are organized into different little tabs. I also had here, this one was complicated. How do you check whether or not you've won? Well, how many ways are there to win? Yeah, we said either 8 or 16, depending on how you counted. Well, how do you check just one of those 8? Well, I had to check basically the top row. So I organized all the top row stuff here, and then the second row and the third row, and then I did the columns, and then at the bottom I had the 2 diagonals. But it was all of this is what it took to check if somebody won, right? Which you can see is pretty complicated. I mean, a lot of it was kind of copy and paste and repeating patterns, but it wasn't horrible. Okay. And actually, you see right here, I've got something highlighted. It still says Kismet. There's still vestiges of that name hidden throughout the editor. It's kind of funny to see it, that they haven't caught all of them. So anyway, okay, hopefully the shaders are almost compiled so we can play this and kind of see that, hey, tic-tac-toe is pretty awesome. Nope, not yet. Okay, we'll just wait patiently. Okay. All right, so I guess what I'm trying to do, since we're finishing off, right, is to give you guys kind of where could you go from here, right? And how can you take the lessons that we've learned in this class and make them transferable to situations you might find yourselves in later throughout your career, your time here at Wabash or your future careers. Who else is seniors in the class? Yeah. What are you guys doing with your lives after this? Huh?
Working in the
Lab?
lab.
Okay. Okay. Just don't go into like multi-level marketing sales. Well, like Cutco, Amway, Vitalife, or whatever. any of those sorts of things.
It's like where you have to recruit other people to do it.
Yeah, that are going to be below you, and you get a little piece of their sales. That's called a pyramid scheme. And yeah, those are bad. Okay. So yeah, don't do that. Um, yeah, okay. Anyway, so but like Excel even or Google Sheets, right? Same difference, right? How many of you guys have used that in some of your classes? I mean, now those of you guys who are in econ or in that kind of side of the house have probably used it just crap tons, right? And it's super useful, and you can actually do some pretty sophisticated stuff with it for uh, doing computing stuff. All right, so finally we're done. Okay, so it says player two wins, and then it reset everything, right? So that was pretty cool. Yeah, I mean it's a stupid, simple little game, right? But we were able to write that over the course of a class or two. Wasn't too horrible. Um, Yeah. So this is certainly a place you can go with it. Now, of course, Unreal Engine is, I mean, you can make a career out of this kind of game design stuff, right? It's Unity has something kind of similar. Um, but yeah. So, all right. Any questions, preguntas, fragen? No? Well, gentlemen, we have come to the end of our appointed hour and the end of our half credit. So, yeah, so like I said at the beginning, pay attention to Canvas because I've got need to post a few pieces of info, kind of end of course stuff, um, and tell you about a surprise. Right. So you guys want to know what the surprise is? Huh? Yeah, you have a midterm. No, I'm kidding. It's not that kind of surprise. So this is the first time I've ever taught a half credit course. Now, how many of you have taken half credit courses before? Has anybody taken one with Blix before? No? He teaches them relatively routinely. So I went to Blix and I said, David, I'm teaching a half credit course. I know you do this routinely. What advice can you give me about half credit courses? He says, don't make the paper due at the end of the first half. Let them have a little bit more time to do it. So, about those projects, when did you think they were due? When are they actually due? No. No. I'm not gonna I'm not gonna I'm not gonna take away time. I am, but I'm not. I mean, come on, don't do me like that. Yeah, it does say tomorrow at midnight, but I will let you guys have a little bit more time. Okay. Yes. So, in particular, I'll let you have basically about another week. Okay. Now, why have I waited deliberately until today to tell you this? Exactly, because if I had told you it wasn't due until the end of break, what would happen? You wouldn't have done shit up until now. Okay. Huh? This ain't my first rodeo. Okay. These are called Jedi mind tricks when you're teaching, right? And I may be a Starfleet captain, but I know all the Jedi mind tricks. Okay. Um, yes. So it is not actually due tomorrow at midnight. And in particular, I'm going to give you guys. So here's what I've decided. Um, so spring break, as far as I'm concerned, is a 2-day weekend. It happens to have 9 days in it. But for my purposes, it's a 2-day weekend. Okay. So the second half, guys, when is their project going to be ultimately due? Well, when their final exam time would be. But we don't have finals week for you guys. Their final would be on Thursday. So when is your project going to be due? Thursday after break. Yes. Okay. Because, like I said, the week of break doesn't exist. Okay. Yes. Okay. The 14th, 15th, 16th, I think the 17th. Double check the calendar. Okay. Yeah, the 17th. Now, that said, please don't procrastinate this. Okay. Right. That's why I haven't told you about this until now. And you guys are sworn to secrecy with the guys in the next class because I'm going to pull the same gambit on them. Okay. Yeah.
That's great. That helps a lot, actually.
Yeah. Okay. I figured you guys would appreciate that. Plus, it also makes up a little bit for the fact that we've missed 2 days. Not planned, missed 2 days, but yeah. Okay. So you can thank Dr. Blix for helping me see the light. Okay. All right. And on that note, well, you can, right? On that note, y'all have a wonderful rest of your semester and day.